Hello everybody and welcome to this webinar. My name is Lee Snyder, the product manager for the Still segment here at Trimble. And today we're excited to talk about Estimodeling using Qnect and Tekla EPM. Our presenters today will be Henry Letterman from Qnect, as well as Ricky Horton from Fabrication Information Systems. They'll do their own introductions, so I won't take the time to do that here, but you can see their contact information on the screen. We'll also include that at the webinar, so if you have any questions later on, feel free to contact them directly. We will also be answering questions throughout the webinar, so as you have those, feel free to use the chat in the GoToWebinar interface, and we will respond as we can and follow up with anything after the webinar as needed. So Henry will kick off the webinar for us today, and I will turn the time over to him.
Thank you, Lee, and thank you, Trimble, and especially Lee, for helping us get to this point and to be able to present this webinar to you today. I'm Henry Letterman, and Executive VP of Qnect, and I'm delighted to be here with all of you. Today's agenda will be first, I will do the how to connect your model and what value data you can extract from it. And Ricky will do the second half, how to get that data through Tekla+'s EPM, and some tips and tricks. Please use your chat window for any questions. We'll try to answer any we can today, but we certainly will follow up, make sure you've gotten answers to your questions. On the part that I'm going to do, there are going to be actually two parts. The first is how do we get the data into the model, and the second part would be an introduction to analytics, which is a whole new and robust and complete data set of information to help you choose the best decision for your company and for the job, and to help you be even more competitive. So let's get started. So the first thing that happens when we set up a Qnect job is that we have to set up the preferences on the website. So let's go to the website and show you where that and how it happens. So here we're on the Qnect website. We have the job name, and we have all of the parameters that would go into what would be needed to design a joint. Qnect also creates custom components, and of course all of that is based on this information. Connection types, forces, we're not going to go into this today. This is set up once at the beginning of the job. Detailing preferences, minimum job requirements, minimum plate thicknesses, angle sizes, bolt selections, welds, moments, vertical bracing, etc. And so that, once it's all filled out, takes about 40 minutes. It can then get copied to further jobs, become the basis from day one to the last revision, as the parameters and preferences to design your joint. But the one other thing I want to bring to your attention today is these three settings: preference optimization, bolt optimization, and doubler optimization. I'll show you more about preference and doubler later, but a word on bolt optimization is how we reduce bolts on a job anywhere from 2 to 4 bolts per ton. Again, very important as you're trying to tighten your bid. And we do that by varying the vertical bolt spacing from 3 to 6 inches in half-inch increments, or in any pre-selected vertical spacing that you would prefer: 3 inch, 4 inch, and 5, 3, 4.5, 6, whatever you would like us to conform to, as Qnect is built with a lot of flexibility to meet your needs. Once that's set up and that information has been captured, then the next thing you would do, we'll go to the model. And in the model, we will do some preparation ahead of time, which doesn't take long. But once that's done, and especially on the Estimodeling side, we'll actually select the entire building. When you download Qnect's app, it will show up as its own ribbon, Qnect, in the ribbon, and you'll see buttons 1, 2, and 3. You simply select the whole building. Now, anyone can do this. Your estimators can do this. We can do it to support your training so you can get good at it. And you select the whole building, you hit button 1. Qnect grabs all the data, brings it up to the website, organizes it by beam to beam, column flange to column web, embed plates, moment connections, bracing, engineers each joint custom, and makes a custom component. Sends you an email that says it's ready, and then you hit button 2. Qnect then pulls that data down, and in one quick snap, it populates the model, which I'll show you in a second, some of these connections. But what I want to say here is about the extraordinary speed. In addition to integrating connection engineering and detailing, we will do that in such a fast fashion that this entire building, whatever percentage Qnect is able to do, 60, 80%, we'll do this particular building you're looking at in easily less than an hour. There really has not been a building, we've done 80,000 tons, that we couldn't do in a few hours. So that's important to understand because it leads into the opportunity that becomes available to us in the preference optimization, which I will discuss later. So we hit button 2, it comes back down, and as we can see, all the connections, or quite a few of the connections, a large percentage is in the model. Qnect has managed in this particular job, which by the way is currently in the bid stage, and we mapped all of this information for the bidder or bidders. You can see the stabilizers are not here because we were able to eliminate them. We've got double angles and connections everywhere, as you can see. So we've got the data. The job hasn't been bid yet, and we now have a huge understanding of this job because not only do we understand what got connected, but we also have an understanding of what didn't and why it didn't. That could lead us to understand a little bit better about how to bid this job. We also know, for example, how many doubler plates are required if the beam has been coped and is inadequate for the load. So really, this is the point you want to get to in your Estimodeling process to then be able to take this data and transfer it into the EPM software. Now, clearly we don't do 100% of the connections, and there's certainly ways for you to understand what we didn't do and then how to do that conventionally so you can capture all of the data in your system. But again, speed, integration, and we're also optimizing the joints to maximize your opportunity. This is all about data, right? This is about moving from just taking 10 to 20% of the total tonnage as fitting material to really getting refined and in understanding what it actually is. Is it 8%, 10%? But it goes a little beyond that, right? Because it also includes a complete understanding of the whole building based on what connected and what didn't connect. Again, all about data. Data allows us to be more competitive. Data allows us to even condition our bids when we understand something that we want to make sure that we're not going to end up with a liability. So it's all about data, data, data. And right now we would just say, let's turn this over to Ricky, and he will then show you the next phase of the Estimodeling process in the EPM. But as I promised, I want to take you into analytics because analytics ties directly into Estimodeling, and it certainly ties directly into production as well. So analytics is where we offer important and significant early data and computational analysis to support better decision making. Let me show you what I mean. Here's a job we're helping a client win in a bidding stage. Engineer says, fill the beam up, but designed for 66 skips. And as you can see, it's worth 159, so a lot of inefficiency. So we said, we're in analytics, we're in Estimodeling. Let's eliminate the fill the beam up. Let's see what happens. As you can see, the connection drops in half. Again, we're talking about jobs where we have the opportunity to design. If this was a mandated job, we would simply mimic the connections, capture the data, move it to the EPM process. So moving on to this example, so we now have a connection that's half this one, and at this point, as a bidder, you're not going to reduce your price because you don't have permission, but you could condition your bid because you can reduce the number of bolts in the connection. So you can condition your bid for a lower cost, lower schedule, or both, pending acceptance of the elimination of this fill the beam up. But let's because we're in analytics, let's pretend that this is where we start. We start with a pretty efficient joint. We can't imagine getting better. It's 3 bolts on a 21-inch beam, which is unheard of. It meets the T/2 rotational stability. It's perfectly engineered. Now, you don't have to make it 3 bolts. You could insist on 4 rows, no problem. But we also know this is 2 parts, so we're curious, can we do it in a single part? And sure enough, we think it's still cheaper. We get a few more bolts, but 1 angle 3/8. And now we say, hey, what about if we experiment with different bolt sizes? And here we can see that for a 1/2 inch thick, 1 inch A490, we've gotten what appears to be the most optimal joint and huge discount to the cost. Now, you can decide not to use this, right? Because you'll say, I don't want to use 1 inch bolts, I don't want to use A490s, whatever. But you have a choice, and that's where the full power of analytics comes in, where we're able to actually take that building and engineer it and connect it 9 different ways, trying to mine data that helps us to be more competitive. Each fabricator is going to be competitive relative to their culture, their equipment, and their resources. So let's give each one of you the data that can maximize your opportunity. So the first thing is that preference optimization button I showed you at the beginning, where if you just activated the pop, you would get a report that looks a little like this. Now, in this particular case, we won't look at the dollar signs because all of these dollar numbers are not relative to everybody. And that's where EPM comes in, right? Tapping into your numbers, your costs. But we know at least that the bolts are absolute. So just on a relative basis, we can take a look at this. But baseline is what you said you wanted to do. Then we tried this bolt arrangements with shear plate, 1 bolt with shear plate, different bolt arrangement, extended shear plate, double angles, welded, bolted, right down to single angle. And we make some comparisons. We can see that if you optimized, which is the BOP report that you can activate, you save 9,000 volts. If you looked at this report, you could see that this arrangement netted you another 10,000 volts. Well, that's pretty powerful data to have. That's a 19,000 volt differential that could likely make or break this job. But if you're purely into the double angle range, well, you also get benefit. You got 40,000 versus 29. Or you do a different arrangement of bolts to get huge savings and huge opportunities. Data, data, data. We generally in our industry haven't had time to think, plan, and certainly not to be provided this kind of data, but to be provided in a way that doesn't encumber your process. Once the model is built, within hours you have this data, In fact, saves you time even in the estimating process because you have the model built and now you have data. Now, it would take no effort for us to download the data on the baseline into the model, into EPM data. Take the extended shape plate. You can, in fact, create a model with all of these different runs, separate models into the EPM, analyze. You may not want to do all of them. You may take 2 or 3 of them and investigate what the outcome is very quickly, early in the bidding process, and still be able to have time to put your bid together. So that's the preference optimization. The other thing I wanted to show you was the doubler plate reinforcement report. And as you can see here, first we tell you, so this happens when the cope of the beam leaves an amount of beam whose capacity is less than the demand. As you can see here, the connection is for 60 kips, but it's only good for 57. Now, not a big gap, but sometimes it's much larger, 33 to 29. The fact is, you can't just use 57. You'd have to get permission. And this chart allows you to identify where in the plan, send an RFI, ask the EOR to reduce it. Now, if it's even a worst case and you can't get the loads reduced, Qnect will show you 2 choices. If you upsize the 1626 to 1631 or an 1835, you will be able to have the capacity, in this case, 66 kips versus 60. Very powerful. Data. Knowing that this job you're bidding will have X number of doublers. And what do you do with that? We had one job where there were over 7,000 doublers, one of the largest buildings that are currently being done. We had to create this map that would produce also an RFI with the load, capacity of the beam size, and the 2 upsized beams to eliminate the doubler. So again, you've got the POP report, the doubler report. I just want to talk briefly about the extended shear plate because, again, all of this is captured early. If you wanted to experiment with an extended shear plate, beam to beam, where erectors tell us that they can erect 30 to 40% more pieces per day, you might want to know what would that look like if your erector knew we were doing this, what would that be as a pricing opportunity? But you have to know the trade-off. Are the plates now 1 inch thick or double pass wells, or are they single pass wells? So you get to examine this, the quantity, the number of bolts, the thickness of the plate. Any cases where it's 1/2 inch shear plates and under a single pass well, this is a great option. We had a job with 6,500 of these, 6,000 were 1/2 inch and under, so we did it as an extended for those. 500 went from 3/4 to 5/8 to 1 3/4 inches, so we did those standard shear plates, maximized the return for this client accordingly. So let's see. I want to just now summarize for you and turn it over to Ricky. Again, we're integrating connection engineering and detailing back in the model extraordinarily fast, while simultaneously optimizing each joint, thereby reducing the bolts 2 to 4 bolts per ton, reducing your time to detail, time to connection engineer, time to fabricate, time to erect. And then we're taking that data in the Estimodeling phase, transferring it through your EPM file right out of Tekla into this next process to then really hone in on your costs so you can be really confident about what you're bidding and how much you can give or take in that last process. So without further ado, it is my great pleasure to introduce my esteemed colleague, Ricky Horton, and he'll take you to the next phase. Thank you very much for spending some time with us today.
Thank you, Henry. Before I begin, I want to point out that having Qnect take a model and actually connect it is a huge advantage when you're doing the Estimodeling and bringing it into EPM. For one thing, you could bring it in, you could rerun the connections for value engineering and bring it in and see differences very quickly in your estimates. That's a distinct advantage there. I'm going to bring in here just to demonstrate. I want to bring in this model. I'm going to import it in. You'll see it's just an IFC model. A couple of goals that I want out of this in the short amount of time we have is just really to help those that are just beginning with Estimodeling. Just what do you look for? What labor automatically comes in? What labor might be missing? How do I make sure all the labor gets covered? I just want to get you on the right path on that to begin with. And Daniel Lopez covered some of this, and hopefully I can just take what he's done and elaborate and a little bit more as well. So hopefully you'll get enough out of this. I want to import this IFC model, and so let me go ahead and close this and go back to EPM. In order to do that, I'm going to go File and Import, and then I'm going to, under Estimating, choose IFC. This is the one that I want to select. It's just an IFC file. So I'm going to say Import, and when this happens and it starts running, it's going to pop up here in a minute, and I'm going to put in a estimate and tell it which estimate to dump into. So let me just put in a job real quick. And I can call it test IFC import. Do whatever. I'm not going to take the time to do a detailed setup here for this, but then it's going to go through and start importing the IFC model. A couple things to note as this is importing. It'll take a couple minutes, being a larger model. A couple points to think about. Know what is in the model. So if you begin Estimodeling, you really need to have some sort of detailing standards when you do it, so you know that what is coming in. Is welding coming in? And if welding is coming in, is that all of the welds? Having part of the welds is almost as bad as not getting welds. So are they coming in? Are holes going to come in? Are copes going to be coming in? So know what you're going to be getting when you have somebody do that model, or else you do the model for yourself. You need to know what's going to be coming in so you know what labor to cover when it comes in. And there's really not a right or wrong method to doing this Estimodeling. It's just you need to make sure that what you're doing is going to cover the labor when you bring it in. So when we get to this point, you're able to import anything from the model. And one thing that we had was we had copes turned on whenever we did this export. So be sure you get the Estimodeling export and Estimodeling with copes if possible. What I'm going to do, I'm going to map that directly into the copes field by selecting that line item. The EPM field I want to go into is copes. Set that field mapping, so now it's going to go directly in there, and I'm going to say OK. So this is going to import. I'm going to let it go, and then we will hop in there and take a look at the model. Now you're going to get to a point in the import where it's going to ask you if you want to add and link a new Tekla+Qnect project, which you want to say yes. Then it's going to pop up and ask me if I want to invite anybody to the project. Now this would be all the users in the system. I could invite whoever I wanted to. Just remember that Tekla+Qnect is you get into a model by invitation only. Then it asks me if I want to upload the IFC to Tekla+Qnect project. So I'm going to say yes as well, and it'll start uploading it and continue with the import. Whenever the import is complete, one thing you definitely want to do is to check to make sure everything came in. You want to check your import log here. So you can see here I had a few issues. Looks like some studs probably didn't come in here, but you want to check this to make sure, hey, if something didn't come in, I need to include it in my estimate. So this will tell you whether something got kicked out or not. So I'm going to go into that estimate, and I have it right here. So I'll go into it, and you're going to see when I initially go into it, I've got everything in. So at a bare minimum, you've saved a lot of takeoff time, a lot of typing, which will save a lot of errors as well, or a lot of potential for errors. So I've got all my pieces in here. So I'm going to go ahead and open up the model. So if I go to model interface here, it's going to go out to Tekla+Qnect and open up that model. And here's my model that is connected to it. One of the first things I like to do is just look around the model. What am I getting in the model? What connections are here? Make sure I kind of understand what's going on with my model here. So take the time to do that and get familiar with what came in. But then also, one of the first things I like to do is to just colorize the model by anything here. I'll colorize by category. And what it will do is, if I go back out to the model, you'll see here that I'm going to get a colorized model based off of all the categories. One thing to point out in particular is that the dark blue is not in Tekla EPM. In other words, anything colorized dark blue is not in your estimate, and that is extremely important. Don't ignore that. So if I go over there, I can start browsing around the model, just looking for anything that's dark blue, and you can pretty quickly see if you do have anything or not. And it looks like most of my members ought to be in there. I'm not really seeing anything dark blue besides these walls down here. So, however, what you still want to do is when you come back over here, I'm going to hit check none. All of these are going to be unchecked, and what that does is anything unchecked disappears from the model. So I'm going to check this not in Tekla EPM so that it turns all of that back on. When I go back over there, I can start looking to see if I have any members that are not, that are still showing here that should be in there. That's just the grout and bolts. Looks like I had some bolts not coming, but I do see right here, there's almost studs that didn't come in. So you can find out pretty quickly if something didn't come in, if you need to account for it in your estimate, just by colorizing the model that way. So I'm going to check all those back. Now, there's one thing you need to make sure is what labor came in, right? And I've harped on that a little bit. Notice that A code is right here. A code is the default code out of the box for what your labor code will be. So everything should be an A labor code when it comes in if you have the out of the box. Just want to look and see. Let's go down to this one item, 1167 and 10. And if I look at this piece, I just wanted to go to this piece to show you that I do have holes coming in. I do have copes as well on the copes field coming in. If I right click on that and say select in model, when I go back over to the model, you'll see it's zoomed in on that piece. If I go down there to that piece, I can see that I've got connection, I've got copes, I had holes, all of that came in. So that information was coming in, which is great. And if I go over here and actually select the associated plate, I go back up here and go right click and select from model, you can see I've got welding there as well. So that plate's been welded. So I've got welding, I've got holes, I've got all that coming in. But there are some things that are still not covered by that. So if I go back over here, select that beam again, right click, select from model, and if I double click on there, you're going to see here I don't really have any layout besides just laying out for copes. I don't have any fit up in here. I don't have any QC. So it's just I've got some holes in the labor there. So how do I fill those holes is one of the things that we need to cover. There's several options for that. Daniel Lopez covered some of those. I'm gonna go over some as well. You can take labor codes and then use the labor codes to fill in some of those gaps if you wanted to. If I go over to labor codes, you're going to see that I put in a couple as examples. Like a V code is just going to be plates on both ends. basically for shear tabs on both ends, and it's going to add those shear tabs as well as the put the fillet weld on them, right? So I put in a couple other codes. One of them I put in as V, then I just did a W to notate that it has no weld on it. If I go over here to the formulas, you'll see that it's putting the plates on, but I did not put weld on there. Of course, if welds are coming into the model, I would not want to add welds and double up, so you could use that code. I added another code here that has no clips or no welding either. So if you got a connected model that has welds coming in, then you could do that, and you're not going to add any clips on. But I do get the move, layout, fit up, and check for the plates. So this is a means of putting that on there. So let me just illustrate a little bit here. Let's go back to my estimate. Let me go to, let's see here. Let me go to line item, or page 482, item 10, to look at this one. The filler beams, let me select that in the model. You're going to see that this has no connections on it. So you really need to handle that. You need to handle the material as well. So I could take that and put a labor code on it to do that. If I look at item, let's go to 65 and 10 here. Select that in the model. Then you're going to see the same thing here. I've got no connections, and I have no welding, got no labor, got no coats on that. I start seeing a pattern here. Well, I'll check through the model, and if I looked at all of that category, which was small filler beams, then I can go I can filter for small filler beams. I can even go down to the shape of W, and that's all my small filler beams. So I can highlight all of those in the model, and I can select all of them, and then select in model, and it zooms out, and all of them are selected there. Now I've gone through there and see that those are not connected. So if I can simply take all of those and go estimating, global edit selected. Then I'm going to put a V code on there. That's going to add clips. That's going to add welding as well. And let's put two coats on there as well. And we'll select that. And then one other thing you can do when Estimodeling is to use this status and say, hey, I'm marking these as completed. I've taken care of it. I'm good to go. And then I'm going to update that model. So that status, I could even colorize by that status, by the way. If I go to status and colorize, then I'll be able to see which pieces are completed and which aren't, just by the colors of green there. So the other way to really handle this too, and to fill a lot of those gaps, is to use an estimate extra. You could build an estimate extra for Estimodeling that adds some time in, basically as an average across all for check, fit up, layout, and move. Any other ones that you wanted to build to fill out any holes in the labor that you're going to have coming in on your model. So I could very easily just take and say, hey, I want to go global edit across all the pieces. If I could filter for anything that I wanted to, but I could global edit across all the pieces, apply that Estimodeling estimate extra, and now I would have fit up, layout on and QC, and a little bit of move time that was missing in there. So I'm going to close that and say I'm going to add to existing, just in case I had any other estimate extras in there, and then everything gets updated. So this just helps you get a jump start on what you can do in order to bring a model in, what you need to, some of the things you need to look for, and then a couple ideas for how to fill some of those labor gaps. But this can be very effective for you, can be a very big time saver for you as well. Really encourage you to jump in there, because at a bare minimum, you're going to save time from just not having to manually enter all of that. So you are going to save time. You'll be more accurate, and then you can go through the model and see how you need to fill those gaps in the labor. Hope this helps. Hope all of this is a help to all of you. Please let us know if you have any questions.
All right, thank you, Ricky and Henry. We really appreciate the presentation today and you taking the time to come present to our audience today. If you'd like additional information or would like to contact Ricky or Henry, again, you can see their contact information there on the screen. If there's anything from the Tekla structure side that we can answer for you, feel free to reach out to us as well. And we hope that you'll join us for more webinars in the future. Thank you, everybody, and have a great day.